Okay, so in the previous lectures we have seen how to convert a decimal number into a different number with some different base. Okay, so now we are going to see how do you convert any number from some different base into a decimal number. Suppose you are given a number like this: x2, x1, x0 dot x minus 1, x minus 2. Okay, you are given this number in some base r, some unknown base r, and you have to convert it into a decimal number. Decimal number means a number with base 10. So see, we applied the concept of weights here. Okay, what is going to be the weight of this LSB? This is the LSB of the integral part, right? So what is going to be the weight of this? It is r to the power of 0. Okay, what is going to be the weight of this bit? It is r power 1. This has weight r power 2. Similarly, for the fractional part, the weights are r power minus 1 and r power minus 2. So what are we going to do to obtain the decimal equivalent of this number? What we are going to do is, you multiply the corresponding digits with the weight of that bit. That means, see here, the digit at this bit is x2 and the weight is r square, r power 2. So we are going to multiply these two. So what is going to be the decimal equivalent? It's going to be x2 into r power 2 plus x1 into r power 1 plus x0 into r power 0 plus x minus 1 into r power minus 1 plus x minus 2 into r power minus 2, and so on. So what we can say, this can be written as summation I xi r power I. This is how you are going to convert any number from some different base into a decimal number. Now let us look at some example. See here, we are given a binary number 101101. See, this is the given binary number and you have to convert it into decimal. Let us see. This 1 is the LSB. It is the LSB. What is going to be the weight of this bit? It is 2 power 0. Respectively 2 power 1, 2 power 2, 2 power 3, 2 power 4 and 2 power 5. The weight of MSB of this number is 2 power 5. Okay, now you are going to multiply. We multiply 1 with 1, we get 1. Then you multiply 0 with 2, you getting 0. Okay, then you multiply 1 with 4, you getting 4. 1 with 8, 8. 0 with 16, you get 0. And 1 with 32, you get 32. Then you add all these. What are you going to get? 32 plus 8 is 40 plus 4 plus 1, 45. So the decimal equivalent for the given number 101101 is 45. This is how you are going to convert a number from a different base to decimal. Let us look at one more example. You practice it yourself. Convert 11010.11 into a decimal number. I am giving the answer here. You can practice it yourself. The answer is going to be 26.75. This is going to be the decimal equivalent for this number. Now look at one more example. We are given a binary number 1101.1011 and you have to convert it into a decimal number. See, these are the weights. What is going to be the weight of this bit? It's 1. Fine. And what is going to be the weight of this bit? 2 power 1. Then 2 power 2. 2 power 3. Then we are multiplying this weight with 1. What are we going to get? 1 into 1 is 1. Then you multiply this with 0, you get 0. You multiply this with 1, you get 4. 1, 8. Fine. Similarly, the weight of this bit is going to be 2 power minus 1, 2 power minus 2, 2 power minus 3, 2 power minus 4. And we multiply them respectively with 1, 0, 1, 1. What are you going to get? 1 into 0.5 is 0.5. 0. 2 power minus 3 is 1 by 8, which is 0.125. 2 power minus 4, 1 by 16, which is 0.0625. So these are the numbers that you get on multiplying the digits with the respective weights. Now you add all these. We are adding 8 plus 4 plus 0 plus 1 and so on. what are you getting? 13.6875. So this is how you have converted this binary number into decimal. Now let us quickly look at some other bases. This is a number of base 16 and you have to convert it into a decimal number. Okay, the procedure remains same. What is going to be the weight of this bit? It's going to be 16 to the power 0, which is 1. What is going to be the weight of this bit? It is going to be 16 power 1. This bit has weight 16 power 2, which is 256. Okay, and what does B represent in hexadecimal system? We all know B represents 11. So what is going to be the equivalent number? 11 into 256 plus A represents 10. 10 into 16 plus D is 13 into 1, which is going to be 2989. You can calculate this later. It comes out to be 2989. So the answer is going to be 2989. Now see, here we've got an imaginary base, imaginary number system with base 4. But in this case also the procedure will be same. The weight for this bit is going to be 4 to the power 0. Here it's going to be 4 and here it's going to be 16. So what is going to be the equivalent decimal number? It is going to be 16 into 1 plus 4 into 2 plus 3 into 1, which is going to be 27. 27 is going to be the equivalent decimal number. I am giving here one more problem for your practice. You convert 37.4, which is an octal number, into binary. Convert this on your own. See if you get the answer 31.5. This should be the answer. Just convert and check. Okay, so now we look at a shortcut. You can say this is a shortcut to convert a number from any number system to decimal. We'll start with an example. Suppose we have a binary number 101011. This is a binary number which you have to convert it into decimal. Fine. See, if you go with the conventional method, you take the weights and then you add. This may take a while. This may be a long method. What does the shortcut say? You start with the MSB. This is the MSB. What is the face value of the MSB here? Face value is 1. Okay. So you've got 1 now. Now when you, what is the next digit you want? What is the next bit? You have to append 0. To append 0, what am I going to do is, I multiply this 1 with the base. I multiply it with 2. Fine. So the value becomes 2. And you've appended 0. So you add 0. So the value for these two bits is 2. Now I need to append 1. To append 1, I again follow the same procedure. What I do is, I multiply this with 2 and add 1. What is this? 2 into 2 plus 1 is 5. So the total value of this number till now is 5. Now I have to append 0. To append 0, same. 5 into 2 plus 0. Now I have appended 0. This becomes 10. Again, now I have to append 1 into 2 plus 1. This becomes 21. Okay. Now last one is remaining. To append this, multiply this with 2 and add 1. What do you get? You get 43. Try with the conventional method. We are going to write the weights. 1, 2, 4, 8, 16, 32. See, just add 32 plus 8, 40, plus 2, 42, plus 1, 43. So you've got the 43. So this is a shortcut. Maybe if you practice it a lot, you'll get comfortable with this. You can use this. Now we're going to see from where did we get this shortcut. You can easily see this with the help of a decimal number itself. Suppose you have got a decimal number 765. Okay, so we are just trying to verify our shortcut. What is the face value of this number? 7. If you have to append 6, then what do you do is you multiply with the base and add 6. Okay, you have appended 6. Now if you have to append 5, what you do is you multiply with 10 and add 5. just quickly see what is this going to be. This is going to be 70 plus 6 into 10 plus 5. This is going to be 760 plus 5. See, you've got 765. So the base for this shortcut is the decimal number itself. Also, you can verify like this. You remember at the starting we took a number like this, x2, x1, x0. I'm ignoring the fractional part for now, but you can take it later. This is a number with base r and we wanted to convert it into decimal. Now let us apply this shortcut to this. What are we going to do? The face value of x2 is going to be x2. When I want to append x1, what am I going to do is multiply with r and add x1. Then further, if I want to append x2, what is required? Multiply this whole number with r and append x0. Let us quickly see what this value is going to be. x2 into r. R is here and you're multiplying it with r, so you get r square plus x1 into r plus x0. If you apply the formula also, the one we learnt, we got the same thing. Got the same thing, right? This is the same thing that we got here. Summation I xi r to the power of I. See? So this verifies the formula. Now it is up to you how much you practice the shortcut. If you practice it more, it will be very useful. It will be useful especially when you have an unknown base. Like if you have a base 5 number. Okay, so we are given a number 203 with base 5 and you have to convert it into a decimal number. Let us apply the shortcut. What is the face value of 2? It's going to be 2. When you have to append 0, what you do is you multiply with the base and add 0. This is going to be 10. Now I have to append 3. So what I do is I multiply with 5 and add 3. So what is this number going to be? It's going to be 53. So you see how quickly we are able to do calculations using this shortcut. So maybe you can practice it and you will be comfortable with the shortcut. Okay.